Hi and welcome back to Module 7 in Organic Chemistry, and today we're looking at Inquiry Question 3, which is our reactions or products of hydrocarbon reactions. And today we're looking at the outcome below, where we're going to look at, in class, some modelling of the unsaturated hydrocarbon reactions, including reactions with hydrogen, halogens, hydrogen halides and water. So we've already looked at alkanes with our saturated reactions, but like the alkanes, our alkenes can react in combustion reactions, but different to the alkanes, our alkenes and our alkynes are much more reactive. Our alkenes are our unsaturated compounds, meaning that they contain a double bond, and our alkynes contain a triple bond. And this bond makes them more reactive than the alkanes. So what we're going to do is have a look through these different reactions and how they sort of pan out. So the first one we are going to look at is our addition reaction with our alkenes. So like the alkanes, we can react and create new compounds, but different to the alkanes is that with the alkanes it was a substitution reaction where one hydrogen was removed and forming another product, and the chlorine or the bromine was substituted in. And that was because it was already a saturated molecule and there were no more bonds for the carbon to make. It already had the four. But with our alkenes and alkynes, that's not the case. It's an unsaturated molecule, and so there is room for other atoms to attach to that carbon. So that double bond actually has quite a significant effect on the chemical properties, and that's because we can actually add to either side of that double bond by splitting that double bond and making it into a single bond, freeing up some more bonds there for it to bond to other things such as our chlorine, bromine, hydrogen and so forth. So what happens in an addition reaction is we are getting two reactants and they are producing just one product. So as I said, the double bond is broken and it becomes a single bond, and the atoms adding to the alkene, which is now an alkane, is added to the carbons on either side of that double bond. So let's have a look at an example. The first one we're looking at is the hydrogenation of ethylene, or ethene as we see, but ethylene is its correct name. So what's happening here is we have our ethene and it reacts with our hydrogen gas, and in doing so it needs a metal catalyst. One example is nickel. It needs a metal catalyst there to help that reaction go along its way, and we call this hydrogenation, obviously, because we are adding a hydrogen to this reaction, or to this alkene. So what happens? The hydrogen reacts with and then breaks that double bond down, and one atom, as you can see in our diagram over here, it adds to either side of where the double bond initially was. And this is quite significant in our everyday kind of life of chemistry, I suppose, if you call it, because this has got a lot to do with our oils and our margarines. So we can make margarines from our edible liquid oils. So margarine's a solid fat. And so our solid fats often contain our long chain hydrocarbons. Most of the time they're saturated. So we're looking probably more at our alkanes, whereas our oils contain unsaturated chains with one or two multiple double bonds. And so if you think then that when we talk about saturated fats compared to unsaturated fats, or polyunsaturated is often the term that's used with margarines, polyunsaturated, so many, and unsaturated, so many of those double bonds or triple bonds throughout there. So with margarine, that comes from our liquid oils that have gone through this hydrogenation process. What happens then with our alkynes? So it too can be converted through hydrogenation. Again, we're reacting with our hydrogen in the presence again of our metal catalyst. As I said, nickel's one, platinum's another, and palladium's another one that we can use as our catalyst there. So here you can see 2-butyne, and our hydrogen now is breaking that triple bond and making it then into our double bond. And again here, this is the position of our double bond. This is where then the hydrogen is added to on either side of where the triple bond was, or in the case now it is a double bond. Now this one is a little bit tricky. To prevent that alkane continually breaking down and going into an alkane, we use a Lindlar catalyst, and that's a catalyst with palladium, as I said before, but it's deposited on a calcium carbonate, and that's an inhibitor, so it'll only break that once. It'll prevent it from reacting further and going into that alkane reaction. So another type of reaction that we can see with our unsaturated hydrocarbons is one with the halogens. So in a similar mechanism to the addition of the hydrogen, we can add diatomic halogen atoms such as chlorine or bromine to our alkene, and it'll be added across that double or triple bond. So what will happen here is one halogen atom will be added to each carbon atom. So this is known as halogenation. And the product that we'll then get is a haloalkane. So what basically happens in this one is we're getting what is an unsaturated carbon. That double bond is breaking, forming a single bond, and we are then getting saturated carbons because they are bonding to 4 separate atoms, then in an alkane. So the third type of reaction that we're going to look at is the reaction of our unsaturated hydrocarbons. So again, our alkenes and our alkynes, this time reacting with a hydrogen halide. So as the name suggests, there's hydrogen and a halide. So things like your HCl and so forth, HBr. So hydrohalogenation is again that breaking of the double bond, forming a single bond, and this time we have hydrogen and the bromine, or hydrogen and the chlorine, that is going to go either side of that double bond. There is another rule that does determine where that hydrogen and the bromine will go, but it's not actually required at the HSC level to know how to apply that one. So we're really happy enough that you will know that hydrogen will go on one side and bromine will go on to the other side. We don't need to cover that Markanov's rule at our level. If you certainly are interested, look it up, see how it applies. It certainly doesn't hurt to follow correct chemical protocol, but it's certainly not something that you need at this level. So our common hydrogen halides that we're going to use in this unit is your hydrogen bromide, as we've shown in this example here, and our hydrogen chlorides. So now our fourth reaction that we're going to look at briefly here is adding water to our unsaturated hydrocarbons. So for this to happen, we usually have a dilute sulfuric acid as a catalyst there to assist this reaction to occur. So when again water is added across that double bond, one of the hydrogens will attach to one of the carbons formerly of that double bond, and the remaining OH will attach to the other side. Now you'll see here, and I'll just move me out of your way, you will see here that we've got our hydrogen attaching here, and we've got our OH group, and that is forming that alcohol group, which we're going to look at in module or inquiry question 4, and you'll learn a little bit more about that alcohol bond that is there. So in this case here, this is producing ethanol. So the compound that we've just got there is ethanol. Now, ethanol is often produced by fermentation, and fermentation is the general way that they produce it for alcoholic beverages and so forth. but fermentation can't produce the quantities that we're requiring for an industrial level. So often we can use ethanol in many different uses, such as a solvent to help dissolve other solutes, an antiseptic, it's a disinfectant. It can be used to help make polymers. It can also be used as a biofuel, so thinking ethanol in our fuels that we can purchase now. And so we're not able to make it at the quantity that we need via fermentation. So this way is a way that we can make it in industrial quantities and able to fulfill that requirement that we need. So what we're going to do is we are going to look at in class a whole range of these reactions, similar to what we have done with our alkanes. We are going to do some modelling and look at these reactions and actually break them down, model them, have a look at what the functional group is, and we're also then going to tie all this up with some reactions. We're going to actually look at what happens when we add bromine to an alkene versus an alkane and sort of build on those properties of alkenes and alkanes that we've been doing to date. So I'll see you then.